Hello all, welcome to this video on functions. In this video, we will talk about what are functions and why we use them when we program. Further, we will talk about different types of functions, for example, built-in functions and user-defined functions, and also void functions and value returning functions. We'll also touch on variable scope, i.e. local and global variables, and how to use them in functions. And finally, we'll talk about Python modules and how we can use some of the functions that are available within the Python modules by using the import statement. Okay, let's get started. First of all, what are functions? Functions are basically a set of statements that exist within a program as a logical unit to perform a specific task. If you think of any programming tasks, right, many of these tasks can be broken down into specific subtasks. And what we do with functions is that we basically write a bunch of code, right, that can be separated from the main task as a logical unit, right? So why we do that is, first of all, when we can divide a task into subtasks, it helps us with modularizing the code, right? So basically, we're developing smaller modules, right? That is more easily readable, it's more simple. And more importantly, it allows us to reuse the same code again and again and again, right? If you think about any of the examples we talked about in the past, think about calculating, let's say, the monthly salary for hourly employee or weekly salary for an hourly employee, right? Imagine writing a code, right, as a logical unit, and let's say compute salary, okay? And this way you call on the compute salary function every time you want to compute the salary, okay? So this basically allows you to simplify. And if you think about the main program, you just have one line of code that says compute salary given the number of hours, okay? So modularizing and code reuse, and it's much easier to read, much simpler, okay? And of course, for some of the other reasons, it also helps you write programs faster, because sometimes what you can do is, for a particularly large software task, perhaps you can use multiple programmers and you give each of these programmers a specific function that they can write, okay? And of course, it can also help minimize repetition of code, because if you chunks of it that you're using again and again and again, by just spinning them off into functions, you are minimizing the repetition of code. And finally, because you are doing all that modularizing and code reuse and minimizing repetition of code, you can also test the programs much easier, okay? And we'll talk about all this as we go along in this course, okay? So again, functions, basically because it helps us simplify, makes it more readable. It allows you to use this divide and conquer approach, where you take a larger task, divide them up into smaller subtasks, and for each of these subtasks, you, whenever appropriate, you write a function, okay? So hopefully that's clear. So now that we know what functions are, let's already think about some of the examples we've used in the past, especially examples of built-in functions, okay? I don't know if you know this already. We've used in the past, for example, print function is an example of a built-in. We use the print statement, and to me, it's an example of a built-in function that we are using, okay? We've also used this length function, len, and a string value or a string variable as an argument, right, that you pass into this function. So what it does is, in this example, print function prints whatever is inside, right? If it's a variable, it prints the value. If it's a constant, then it's going to print what's inside in the quotes, okay? And length function basically computes the length of the string. So in this case, the length would be 5. So you've been using this in the past. You haven't really thought much about it. Thankfully, you don't have to write code, for example, right, to calculate the length of a string. You can, if you choose to, calculate the length of a string value from scratch. But since Python is making available this function, right, that's all, someone has already written the code, so all you need to do is pass an appropriate argument, right, that's valid, and it will spit out the length of the string, right? And this is what I mean by modularizing and code reuse. We're using code that someone's already written. In this case, Python is already giving you a function to compute the length of a string. Okay, so you don't have to rewrite or reinvent the wheel. Okay, and so in the past you've done this, and you also returned the print statement, but you probably did not do this. You did not say, you probably just did this, print hello. But here I'm explicitly saying what would happen if I say x equal to, following the similar format. In the past we've done this as well, y equal to length hello, and it's understood that y is going to be basically the length of the string value that's inside the length function. Okay, so to me this makes sense, right? Because this function happens to return the length, and you're capturing that value, assigning it to a variable y. What would happen if I assign this, whatever value that's being generated by this function, and assign it to a variable x? Does it make sense? Typically we don't do that. We do not do this, right? We just say print hello because it does something, it outputs whatever is inside here. But what would happen if you type in x equal to print hello? Let's see. Okay, what do you think are the values of x and y? First of all, are we going to get any error messages? And if not, what would be the values of x and y? Okay, so as you can see, we did not see any error messages. Print hello, as expected, generated this hello, right? And presumably whatever value was returned by this function, right, print function, is assigned to the variable x, and whatever value that was generated by this length function, in this case it should be 5, is assigned to the variable y. Okay, so let's see what these values are. Okay, so I'm basically saying print, the print function returned, what did it return for x, and what did it return for the variable y. So let's run this code and see. As you can see, x, the value of x is none. So basically this returns a none data type. Okay, it's a specific data type with value none. And the length function returned the value 5. Okay, so this basically, the first one basically tells me that this is returning a none data type. So it's something that we don't have to worry about. And for future, this basically means it really doesn't really make sense for us to type in that variable x equal to, right? That's why we don't do that in normal practice, because it returns a value, but it's a none data type we don't really use. We just let it go, right? On the other hand, the other function returned a value that's quite useful to us, and we do want to capture it. We can choose not to capture it. It will not return an error message. It will not return an error message if you don't do this, right? But the whole point of us presumably doing length function is basically because it returns a value that's useful, and we want to capture it. Maybe we want to print it, or perhaps we want to assign it to a variable called y. Okay, and so one way of thinking about this, the reason why we had this discussion, is that think of the first one, the print function. Obviously, it's a built-in function, right, in Python. It's also a void function, meaning it does not return anything useful. Okay, and the second thing would be the second function, which is also a built-in function, right, in Python. It returns a value, so I like to call it as a value returning function because it returns something that's quite useful. Okay, if you go back up here, I talked about built-in functions. So both print and len are built-in functions, and one of them, the print function, is a void function, and the length function, the len function, is a value returning function. Okay, in some places you may hear the term fruitful being used instead of value returning. They mean the same thing. Okay, so value returning or fruitful function, len is an example of a value returning or fruitful function. So I hope that's clear. So this is basically Python providing us with some built-in functions. Okay, and the question is, what if you wanted to write a function of your own? Okay, then you would have to basically define your own function, and that's user-defined functions. Okay, and that can be either void function, which is if it doesn't return anything that you want to use. It can also be a value returning function. Okay, so that's what we're going to be seeing in the next few examples. Okay, so let's move on. So if you want to define your own function, what should be the syntax? Okay, so syntax is basically you have to use a keyword def, D-E-F, okay, and then the function name, followed by open parenthesis, a list of parameters, close parenthesis, colon, and then indented code below this colon. Okay, this is the function scope, the block of statements that you would write here. Okay, guys? And so the name of the function, the syntax is quite similar to the rules you have in place when you're writing variables, right? So you have to follow the same variables. If you don't remember what should be the right syntax for the variables, what are the rules you need to follow for writing variables, please go back and review that content. Okay, it's pretty similar to the name of the function would be very similar to the rules you have in place for variables. Okay, so I'm going to move on. So here's an example of a very simple user-defined function. Okay, so here I have this, right? A def statement, as you can see, a function name, in this case print underscore hello, and then open parenthesis, close parenthesis. For the first example, I choose not to have any parameters, which means I'm not passing any values into the function. So there's nothing in there, just open parenthesis, close parenthesis, then a colon. And then you see two statements within this block, print hello, print world. So it's a very simple function that basically prints hello and world in two different lines. Okay. Now I've defined the function, but I haven't really called on it yet. Okay. So how do I call on it? So let's see how I call on a function. So I have print. I'm basically saying calling on function print hello. And here's how I invoke this function, print hello. At this stage, guys, you know what's going to happen? The control is going to pass here. And then, and only now, it's going to go inside the function. It's going to print hello, print world. Okay, so let me repeat this. When you started running the function, again, it's top down, right? Start from the first line. Python interpreter sees it's a def statement. So it's going to basically register the fact that there is a function by the name print hello, but it's not really going to go inside. It's going to skip this. It's just going to register the fact that there is a definition, function definition by the name print hello. Then it's going to go to the next line. It's going to print this. Now I'm actually invoking the function. So at this point in time, control is going to go back up here and it's going to go here. Print hello, print world. Now the control is going to return to the next line and it's going to print control back to the main program. Okay, so let's see if this actually happens. I'm going to run the code. So as you can see, the first print statement is right here, and then the control transfers here. These two print statements are executed, and then control transfers back here. Okay, again, let me repeat. Top down, first line is def, so the program is going to register that there is a function by the name print hello, and then it's going to ignore everything under this, all the block of statements under this. Then going to move on to this print statement, next statement, next statement, next statement, right? And I invoke the function, the control is going to go in here, then print, all these block of statements are going to be executed, and then control is going to go back to the next statement after the function invocation. Okay, so hopefully that's clear. It's an example of a pretty simple function. Okay, now before I do the next one, I just want to remind you, that there is a stupid magic function. Let's see what's actually registered in the main memory of my computer. Okay, so I use the magic function whos to check this. Okay, and as you can see, not only do I have the x and y, and if you remember, I created these two variables x and y, right? Assigned them to the output from these two functions, so I can see them in the main memory, right? But I also see that print hello is registered here. It's a variable but belonging to the function type. Okay, it's pointing to a specific location in memory. Okay, guys, so please remember this, because when the first line of code is executed, it's basically registering this function definition and saying, hey, there is a function definition by the name print hello, right? And that's what you're seeing here. Okay, so now what I want to do is I want to reset this. I want to erase everything from memory. So I'm going to say yes, I don't want anything. Now if I run this whos command again, there's nothing in my memory now. Okay, so there's nothing. Now what I want to do is something very similar, right? But a variation of this code. So what's different here is that I'm moving the def statement, the function definition, below this line, right? So now I have a print statement calling on function print hello, then I'm calling on the function, and then I'm defining the function. So pause the video here, think about it for a second, and see if you think about whether the program will run. Will it create an error message if the program going to run? Okay, pause and think about it for a second. Now, hopefully you've thought about it. Now let me run this code, and you can see that when I run this, I actually get a name error, right? I get a name error because Python doesn't know what print hello is, because I haven't defined it before, right? So if I really want the program to run, I have to do what I did here, which is define it before I invoke this command. Okay, so it has to be defined before, and that's the case. Before meaning you have to define it, define the functions first, okay, before you call on the functions. So keep that in mind. So if I want to fix it, I have to go back here, and if I try to run this works because I define first and then I invoke the function. So hopefully remember this. Okay. Now I'm going to reset everything again. Okay. If you look at the who statement, it's empty. Now pause pause the video for a second and think about whether you think this program will run. Okay. So now what I've done here is basically I've created two functions. I call one of these functions main, right? And as you can see, I'm gonna clear the output here. As you can see, whatever was there before in the main logic, the main logic where I called on the function, I moved it here. So I'm calling this main function, okay? And this basically tells me how the program's gonna go. Print, and then I'm calling on the function print hello, and this itself is nestled in the function called main. Then I'm defining the function called print hello, it does what it does. And then I come down here, my program literally has one line, main, open parenthesis, close parenthesis, right? Now at this point in time, I want you to pause the video and think about whether this program will run, whether this code cell will run, and whether you will get any error messages. Think about it, guys, okay? Welcome back. So now let me try to see, hopefully you guessed right. I'm going to run the code. I'm not seeing any error messages, right? I'm not seeing any error messages, even though I'm calling on this function before this function is defined, right? Why is that? So that happens because, remember, the main program is really one line of code, the main logic, main, right? Everything else in this program is function definition. So when the program runs, first line, so it registers that there is a function called main. It ignores these two lines. It's not running these two lines. You're not going to see any error messages. And then it registers the fact that there is a function called print hello. It's going to skip these two lines. And then the next line is going to run, calling on the function main. Now the program control goes up here, define main. It's going to print main program calling function print hello. And that's what you're seeing here. Then it's going to call on the function. But now, even though I'm calling on this here, right, the program's already registered the fact that there is a function definition because it started here. There is a function called main, skipped all this. There's a function called print hello, skipped all this. And then it invoked the actual function. The control shifted here, right? And then it's invoking the function. Control comes back to this function, print hello, print world, which happens. And then control shift back to the main function right here. There's nothing else to execute. Then the control is going to go back to the end of where you invoke the main function, right? So the program will run, and hopefully, again, you can pause and understand how the program logic, flows in this program, okay? So again, if you do not remember it, I'm going to repeat myself one more time. Please make sure you understand this, right? Program is running top down, first line of code. Program registers the fact that there's a function by the name main. These two lines of code are skipped. Program registers the fact that there's a function by the name print hello. So these two lines are going to be skipped. Then now the actual function is invoked, main. Because it knows that there are two functions called main and print hello, the control is going to go up here. These two lines of code are going to be printed, right? Print. Then when this function is invoked inside the main function, print hello function, control is going to shift to this function, print hello, print for world. Control is going to go back up here, and then the control is going to go back to the end of the main invocation. Okay, so I hope this is clear. If not, please go back and re-listen to what I just said. Okay. So let me see what's in the interactive namespace. As you can see, this main, this print hello, two different functions pointing to different locations in memory. Okay. I'm going to reset everything so that everything is white plain. I'm going to move on to the next example. Okay. All right. Now we've talked about so far functions that don't have any parameters, right? Now what I would like to think about functions that take in some parameters. Okay. Now think back to the example that we solved in class, where you ask the user or the employee for the number of hours, right? And an hourly employee worked in a week. Okay. And in this example, we basically set the base hours, which is anything above this number, the employee is going to get overtime, and the base pay for the employee is $20 an hour, right? So if the employee worked for more than 40 hours, right, then the employee is eligible for overtime pay, and the overtime pay is going to be, you subtract the number of hours worked from 40, right? So if the employee worked 50 hours, the overtime hours are 10. And so the overtime pay is your base hours, 40 multiplied by base pay. And the overtime hours, in this case, 10 hours, because he or she worked for 50 hours, multiplied by base pay multiplied by 1.5. Because instead of $20, the employee is going to be paid $30 an hour just for those 10 hours, right? So the employee's pay is going to be 40 multiplied by 20 hours. And then the remaining hours, 10 multiplied by 30 hours. Okay. And then that's the logic that's going to be executed, right? If the employee worked overtime, if the number of hours is not more than 40, let's say the employee worked for 30 hours, then the pay calculation is straightforward. It's 30 hours, whatever the hours employee worked, multiplied by the base pay, that's 20. Okay. So you can understand that it's a two-way conditional structure. If the employee worked overtime, you have some logic here to calculate the overall pay. If the employee did not work overtime, it's pretty simple, different logic to calculate the pay of the employee, right? And then I can print the pay of the employee. So imagine that I move this code. We did this in class before, right? I move all of this to this function, right? And I call this function compute_pay. This function takes in one parameter, hours, right? This is the parameter I use. And now my actual program, that's outside of this function, is basically taking the number of hours from the user, right? And then compute the pay. So I'm invoking the function, and because this function takes in, right, a parameter here, so I'm passing it. So this is called an argument. I'm passing an argument to the function, and this is a parameter. So I'm passing the argument, right? And that's going in as a parameter here, right? For example, if the user types in 40 hours, right? 40 hours is a variable that gets passed here. And then that's going to be 40. And I'm going to be comparing 40. Is 40 greater than the base hours? In this case, it's not, right? So it's going to be 40 multiplied by 800. So let me run this. Okay. The employee worked 40 hours. The pay is 800. The employee worked 41 hours. And the pay is 830. Because the 1 hour extra, that's going to be paid at the rate of $30. Okay. But the idea here is that instead of having all this code inside here, I moved all of it out to a different place as a function, right? So that in the actual code, whenever I want to compute the pay, I just call on this function. And all I need to pass on is the simple argument hours, right? And I ask the user to enter that. So again, you can see how the readability of the code is improved because some of the logic, right, is here. And I can now invoke this in multiple places within my code, right? I can repeat this as many times as I want. In this case, again, pause the video and think about whether this is a value returning function or a void function, okay? See how I use this, right? If I assign this, let's say I'm going to call it, right, ch, and I print ch. I want to compute 41, and you can see that ch is none, the output is none, okay? So hopefully you can see that the way I've written the program, the function, right, it's a void function. Nothing gets returned from this function, okay? It takes in some value. There is a parameter here that's here, but it's whatever output, I use a print function to print output, right? But in real life, maybe what would be more useful is instead of me printing the pay, perhaps I want to return the pay. So I use this keyword called return, right? And whatever calculation that I did, right, the pay calculation, I'm just returning that value back into the program, into the place where the function was invoked. So now pay is returned and is assigned to this variable called hourly pay. Okay, so this is a different way of writing a function, and this is what I would call as a value returning function. And think back to the example, length. We talked about print and len, right? This is an example of a value returning function where it returned the length of the string and I assigned it to a variable y, right? And the value of y was 5, okay? And then in that example. So here, what I'm doing is I compute the salary and I'm returning this salary back to the place where the function was invoked. Okay? Now I'm going to try to do a variation of this function. Okay. So now you can see that in the past, like we've done only one simple compute pay, but in real situations, you can see how, for example, not only am I computing the pay of an hourly employee, but I'm also computing the taxes. I'm also computing the benefits, let's say, right? And then what I might want to do is I might want to compute the net pay that basically subtracts the taxes as well as the benefits. Okay. So again, I'm not going to spend too much time talking about the logic. This is just a make-believe logic where I'm saying that the base pay, and the base hours would be taxed at 5%, whereas the overtime pay would be taxed at 10%. Then I'm also keeping the benefits flat at 5% of the overall hours worked. Okay, and then I'm computing those benefits and taxes and I'm subtracting them from the overall pay. Okay, obviously in real life situations, this logic would be a lot more complicated. Benefits, there will be some fixed benefits and some benefits. There'll be some fixed component, variable component. This can get pretty complicated, right? But you can see already the usefulness of this model where all these logic, the logical units, right? The chunks of code, I put them in different functions. And the main code that I'm writing here, again, I'm taking in the number of hours, I compute the hourly pay, and then I compute the net pay by subtracting the taxes and the benefits. Again, notice how I'm using this slightly differently from before. For example, I'm not assigning compute taxes function. I'm invoking the function. I know that it's returning something, okay? So when I return this, I know that it's going to be a number that's coming back, right? And so I'm just using it directly instead of assigning it to a variable, okay? Keep that in mind. And by the way, I've intentionally incorporated some errors, okay? So let's run the code and try to see what error comes up. And then let's see if we can work our way through the problem, okay? But you can definitely see the benefit of taking logical chunks of code, putting them in functions, so that when you're writing the rest of the code, that can be much more, neat and simple, okay? And I can reuse the code in multiple locations as well, right? So let's run this code. let's say the number of hours worked is 41. So suddenly I get an error message. Okay, it says name error, and let me scroll down. The first error seems to be somewhere here, hourly pay, right? And then it says trace back, and it says the name base hour is not defined. Okay, there seems to be some issue here. So I'm going to go back here, and it basically says here, right? The computer doesn't know what base hour is. Okay. So again, think about it for a second. Pause the video here. It's slightly tricky, but why do you think the computer does not recognize base hour? Okay, think about it. Pause the video. Take a few minutes. Okay, welcome back. So here's where I'd like to introduce this concept of local and global variables. Okay, so anytime I use a variable inside a function, that variable is going to be only available within that function. And hence, if I try to use the same variable outside of the function, let's say in a different function or even the main line code, I'm not going to have access to that variable. Okay, and so you want to be very careful. For example, I could even use similar variables, same variable name in different functions. They will be quite separate. Program will keep track of the variables used within that function. Okay, and it's not going to be available outside that function. Okay, and if you use a variable with the same name elsewhere, and even if you define a value there, it's basically going to be available only within this function. Okay, in this example, I'm using base hour, but I'm not really saying what base hour is here. I could, for example, say base hour is 5. Then it's basically going to, now it's not going to give me that error message. Instead, it's going to use a value of 5 here. Okay, so you want to be very careful how you use these values and variables. Okay, here my purpose is in using base hour and base pay, I don't want this to change at all, right? I want to use this, right? I want to say that anytime the hours is more than 40, I want to have the overtime calculated. And I use this for a base pay rate of $20 an hour. So I may have to make this available to all the functions. So maybe one way for me to do this is basically move this perhaps here to the main line code. That's one way for me to do that. Okay. So let me go down here and see how I do this. So the way we've solved the problem here is I've moved the base hour and base pay outside of the functions, so that those variables that are outside of the functions will be available in that program, right? So it'll be available to all the functions. These are all examples of global variables: base hour, base pay, hours, hourly pay, right? They're all global variables, okay? And they will be available to the whole program. On the other hand, if there are any variables that I use within this program, right? For example, pay is a variable that I'm using just within this function. So it's only going to be available within this function. So the only way for me to access this variable outside of this function is actually to use a return statement. And in which case, so whatever variable I return, again, by the way, it can be multiple variables I return. I can use a comma and return multiple variables. Similarly, obviously, I can use multiple parameters, right? Right here. So the only way I can access this variable pay outside of this function is by using a return statement. Okay, so keep that in mind. By the way, this idea of variable scope, global and local variable, is a lot more complicated than this, and there are lots of finer points, a lot of possibilities, and I'm not going to go over all of them in this video. But again, if you want to know more about it, you can always go into a book that talks about functions and try to understand the finer details. There are a lot more details that I'm not touching on. I'm just giving you the broad overview of what you need to create functions and to use them in your programs. Okay. So we fixed one of the problems. Okay. Let's see if the program works. I think you will still probably see another error, and let's see if we can figure out what the error is. Okay. We'll run this code. We'll type in 41 hours, and we again see an error. So at this point in time, I'm going to scroll down a little bit so you can see. Okay. The error seems to be in line 26, net pay, hourly pay minus, then where I'm invoking, or when I'm invoking these benefits. Okay. First of all, I think I made an error, unintentional error in this example. It should really be plus, right? It's hourly pay, and then you subtract both the taxes, you add up the taxes and the benefits, right? And then you subtract it from the hourly pay. So that's the actual program. Now, the error is still there. I think if I run this code again, you'll still see an error. Okay, the error is going to be, just so that I can convince you, I'm going to type this in. So I run this code, and you still see an error, unsupported operand type for plus, float, and none type. This is the error. So hopefully this triggers something, based on whatever we've been talking about so far, and hopefully you can go back up here and fix the error. So at this point in time, please pause the video, okay, for a second. Look at the video, look at the code, and please note what the video said here, right? Unsupported operand, like whatever that's around the plus sign, right? Seems to be a problem somewhere around there, okay? And again, it's a clue. So you're going to have to look at the code, try to see if you can figure out the actual error, okay? So please pause, check to see if you can fix the error, okay, guys? So hopefully you noticed that the error is basically because one of the functions seems to be returning a none type, meaning it's a void function, not a value returning function, meaning perhaps the return statement is missing in one of these functions, right? Because it's not returning any values. I mean, you're trying to add, right, a number with a none data type, and that's why you're getting an error message. You're saying that you can't really add a number with a none data type, okay? So in that case, you can see that maybe I can fix the problem, right, by typing in return, right, perhaps benefits, something like this. And if I run this code, 41, now it seems to be working, okay? So hopefully you understand the idea behind functions, right? You understand value returning functions and void functions. You also understand built-in functions. These are print and length, len function as examples of built-in functions. And we also talked about user-defined functions, right? Where we define the function and we pass the functions with or without parameters, right? If there are parameters, obviously we need to pass an argument to that function. If you don't, again, we'll get an error message. You can always try invoking a function, this function, without any numbers in the valid data types in there. If you just try running this, you're going to get an error message. You can try it on your own, okay, if you wish. But here, you need to pass this argument so that it can be used as a parameter here, because that's what I'm doing, okay? Now,